Hello and welcome. Today I wanted to show you a special function for measuring the resolver feedback pole number using our digital motor controller and the program Drive. My system setup consists of an Bamocar PGD3 400/400 RS motor controller or drive system and an Emrax 208 high voltage motor with a special Tamagawa resolver with 5 pole pairs. For demonstration purposes, I have set up a little camera and I already have connected our Drive program to our Bamocar drive system using the corresponding COM port channel. Like I stated, a lot of times the motor configuration might be known, but the resolver configuration could be unknown. And even after a successful measurement of the FB offset angle using the phasing program, it can happen that the feedback pole number is incorrect, and when you actually try to operate the drive by sending a speed command, just keep in mind I have limited the AC current output to just 5% for safety purposes, and I enable the drive and I send a speed command. The motor is not rotating but is actually just stationary with a high AC current. For safety purposes, I disable the drive and wonder what might be the problem. The phasing rotating process was successful, but the system gave me a logic feedback offset value, but the motor is not rotating properly. This is mainly because the feedback pole number is not configured correctly. This is quite difficult if you do not have the data sheet to the resolver, but there is a way to identify it by using our special tuning algorithm called increments or resolver poles. For this special tuning function, we have to limit the AC current output to a small value. I recommend using 5 or 10%. The motor must be free running. There should not be any blockage for the motor. And what is also very important, the motor pole number must be configured correctly. Luckily, in the case of an Emrax motor, Emrax is providing us with the correct number of 10 pole pairs, which we enter in our case with the pole number, which is 20. We start the tuning process. We enable the drive. The motor will have a current on the AC phases. The motor will rotate 360 degrees, and the internal algorithm will calculate the feedback offset, feedback pole number. We disable the drive. Just as a note, it can happen that we get a ADC measurement warning, but you can ignore it and clear it with the clear error button. After the measurement has been done, we have to reconnect with the drive for updating the parameters. After reconnecting to the drive to update the parameters, we can already see that the drive has calculated a new pole number for resolver of 10, which we can just save to the drive, go back to our tuning process, start the phasing rotating process, enable the drive. The motor will rotate 360 degrees again. And we'll measure the new feedback offset angle due to the new feedback pole number. We enter, we save it to the drive, and then we can test by enabling the drive, center speed command, and the motor will rotate and control to the desired speed command in positive and in negative direction. We disable the drive, we save, and we have finished measuring the feedback pull number. Thank you very much for listening. I hope this video will help you, and happy controlling. Bye.